ladies and gentlemen, my name is Mr. Do and science is my business. You're welcome to Mr. Do Science World, and today we're going to look at dynamics part 2. Last time we started with the dynamics and we ended at a point where we were looking at the net force in a plane surface. Today we're going to look at the net force in an inclined plane, and after that we're going to deal with rare calculations that involve both forces acting on a plane and the one acting on an inclined plane. Alright, let's begin by looking at what we mean by an inclined plane. What is an inclined plane? An inclined plane, which is also known as a ramp, is a plane surface or a flat surface which is tilted at an angle that is used in raising or lowering an object. So let's look at a situation like this. If I have this, this is referred to as the inclined plane, and there is, say that we are having a mass or an object which is placed on this, and we are having it at a certain angle at this point. So if you're having it at this point where we are having this as the angle, we can talk about the Freebody diagram that is acting on this particular object. And in this case, we can see that we can talk about the Freebody diagram by looking at it from this point, and we can see there is a normal, and we're going to have the weight of this object in this direction. And we can also talk about the frictional force, which is perpendicular to the inclined plane. So the frictional force, which I said the last time that with an inclined plane or with any kind of plane that we can talk about, the frictional force can either be FF or we can use FR, and that just simply implies the frictional force. So we're going to try to analyze this and see how we can find the forces that are acting on this. We have already drawn the Freebody diagram, and we can see that there is a normal force, there is a weight, and there is there is a frictional force here. Now we can look at this and say that okay, this weight is also at an angle because this object here is at an angle, therefore the weight is also at a certain angle. So we can talk about the perpendicular component of the weight, and we can also talk about the parallel component of the weight. And we can see this is having an arrow in this direction, and we can talk about the perpendicular component, which is also having an arrow that is acting downward this way. Okay, now let's look at it. We said that the inclined plane is used in either raising an object or lowering an object. So we can lower an object this way or we raise an object in that way. So let's look at it and see from here. This is our Freebody diagram. When I'm drawing the Freebody diagram, one important thing is that we don't draw the Freebody diagram by showing the components like this, but we need the component in the calculation. So if FG is here, this is refers to as FG parallel, or what I will call it as FGX. And this is also a vertical plane, so we can call that as well as our FG our FG perpendicular. Okay, so our FG perpendicular, or we can call it FGY. Okay, so this is FGY or FG perpendicular. Once we have it this way, I will be making use of the FGX and then FGY. I know most of you are familiar with the FG perpendicular and FG parallel. They mean the same thing, because remember, if this is a plane, then this is the on the Cartesian plane. I can call this as the Cartesian plane. So this is my y-axis, and this is my x-axis. Therefore, I can call this the x, and I can call this one the y. So it doesn't matter whichever way you call it. The most important thing is to understand it and to know how to do the calculation. Okay, so let's see. Here is my angle theta. Immediately I have this angle as theta, then automatically this angle here becomes what? Theta as well. So if this is say 10 degrees, then this is also 10 degrees. If this is 30 degrees, this is also 30 degrees. And then we can apply our mathematical knowledge to deal with that. So if I know that this is going to form, this one is going to form a right angle triangle, therefore if this forms a right angle triangle, it means this side is what? Is 90 degrees. And if this is 90 degrees, we can apply Pythagoras Theorem, we can apply our SOHCAHTOA to deal with the calculations from there. Okay, so the hypotenuse in this case is my FG, and my what? My angle, or my side which is opposite to the angle is what? Is the FG parallel or FGX. So that becomes what? The parallel side. And the horizontal side or the perpendicular side is the what? Is the FGY or the FG perpendicular, which becomes the what? The adjacent. So quickly, let's apply the knowledge of mathematics to do this. And that is why I always tell you students that what? Mathematics is the what? The physics is what? Is the life, and the mathematics is the air that keeps it alive. So which means that we make use of mathematics in doing the calculations of mathematics, of what? Of physics. So without mathematics, we can't just do physics alone. So the knowledge of mathematics is very what? Important in calculation of what? Physics. Alright, so let's see. We're going to use this, the mathematics, as a language in solving what? Physics. Alright, so let's see. From here, I've gotten this as my opposite and this side as my what? My adjacent. So let's look at it and see from this point. I am going to look for the opposite. And remember we said opposite against the hypotenuse. You make use of our what? Our SOHCAHTOA and then TOA. Okay, so let's try and look for the components of the what? Of the weight. So we're going to look at the component of the weight, which means that we're going to look at what? Either the FG parallel or FGX. And then we're going to look at what? FG perpendicular or FGY. So let's first begin by looking at the what? The FG perpendicular. Okay. FG perpendicular, if I'm looking at that, we can see that that is adjacent side. So that is going to make use of what? The car. So I am going to say that, okay, it is cos what? Cos theta is equal to what? The adjacent, and the adjacent is the what? Is the perpendicular side or the word FGY. So that is the word FGY all over what? The hypotenuse, which is the what? What is the FG? As I said to you, I will be making use of what? FGY. It is the same as FG perpendicular. Please take note of that. Okay. Alright, once I do that, then it simply implies that my FGY is now equals to FG cos what? Cos theta. And this is the formula for finding the perpendicular component of the weight. Now let's look for the what? The parallel component of the weight. So I want to look at the part of the weight which is parallel to the what? To the inclined plane. And that is just the side which is opposite to the what? To the plane. So I can simply say that it is the what? It is the opposite over the what? The hypotenuse. That means we're going to make use of what? Our so that means that I will say it is sine theta is equals to what? Equals to the opposite, and the opposite is FGX, and that over what? Over FG. Now I want to make use of what? Making the FGX the subject of the formula, and that becomes what? FGX is now equals to FG sine theta, and this is also the formula for finding the what? The parallel component of the weight, or what we call the what? The FGX component of the what? Of the weight. The weight which is parallel to the what? To the incline. So we can make use of these, or we make use of this to find out. Now let's try and find the net force acting on this object. if I decide to do that, we can say that F net, according to Newton's what second law, is equals to what? MA. So if F net is equals to MA, what are the forces that are acting on the object? The forces, we are looking at it with what? With a friction, and we will look at it when there is no friction. So let's look at first no friction. If there is no friction, the forces are the what? They are the normal, they are the what? The FG parallel, okay, and then the FG perpendicular. They are the ones that are acting, or just Fn and what? Fg. They are the forces that are acting. But now let's look at it from the point where we are looking at it, okay? We are looking at the horizontal forces, the net force in the horizontal direction. So I can look at F net in what? In the x direction. And F net in the x direction, where we are looking at the situation where there is no friction, it means that there is going to be only the what? The parallel component of the weight that is only in the x direction. There is no other one again, because here we are saying there is no friction. So if there is no friction, we're going to have this. Let me put here no friction. So no friction means that I'm going to have my F net x to be equals to what? The Fg what? Fgx. Fgx, okay, and that is equals to what? Ma. So this is true, which means that I can equally say my Fgx is now equals to my Ma, and that becomes the what? The net force in the what? In the x direction. Equally, I can find the net force in the y direction when there is no friction, and the net force in the y direction is, so the net force in the y direction is now going to be the forces that are in the y direction. And let's look at it. There is the normal force, and there is what? And there is a perpendicular component of the weight. But now, if there is this and there is this, and that must be equals to what? Ma. So which simply implies we must look at it if the object is going this way or the object is going this way. The object is going this way. So we will look at it from the point where we can see that this one and this one are opposite to themselves. The normal force and the weight are opposite. So therefore we can say that my Fg, okay, y minus the normal force must be equals to what? My Ma. Or we can say Fn minus Fgy equals to what? Ma. Whichever way. Newton's third law. To every action there is equal and opposite reaction force. So here, that is why I am using the negative sign. So which simply implies the net force, which is just the sum, can simply be that it is this one plus this equals to this. And we know when we apply Newton's third law, this side becomes what? Negative. So please take note of that. So this is the sum of the what? Of the sum of the perpendicular forces that are acting on the what? On this object now. Okay. Now I am going to look at it with what? With a frictional force. With the frictional force, the horizontal forces are not going to change. What is going to change is the what? Is the x component. So with the x component, let's check it and see from there. With friction, if I decide to consider friction, once I consider friction from that point, then what I am going to have is F net in the x direction must be equals to what? Ma. And what are the forces there? It is the what? The parallel components of the what? Of the weight and the frictional force. So it's going to be Fg what? Fgx plus plus what? The frictional force, and that must be equals to what? My Ma. And again, remember, according to Newton's third law, To every action, there is equal and opposite reaction force. And what I will tell you here at this point is that it is not automatic, it is a choice and it's a decision to make. If the object is what is moving down the plane, then I will say that the forces that are going in the direction of the object becomes positive, while the forces which are going opposite direction of the forces becomes opposite direction of the object becomes what? Negative. So in this case here, the x component is going in the direction because we are making the assumption that the object is what? Is sliding down. If it is sliding down, then this becomes what? Positive, and this becomes what? Negative. So this also becomes the net force acting on the object when we are dealing with what? Inclined plane. Ladies and gentlemen, one thing that I want you to take very good note of is, in an inclined plane, the normal force is always equal to the perpendicular component of the weight, which means that in a normal force, please take note of that. In an inclined plane, the normal force is always equals to the what? The perpendicular component of the weight. And remember that perpendicular component can simply be what? It can simply be FGY. So in an inclined plane, this is true. Always true. And remember that the normal force itself we know that in a plane our normal force will be equals to what? Mg. Okay, so our normal force is always equals to mg. So if I come there and I say it is equals to mg, but remember that already if we are saying this is equal to this one, what is this? We have already worked that out. It is what? Mg cos theta. Therefore, in an inclined plane, the normal force is always equals to Fg, okay, cos what? Cos theta. That means that it is what? Mg cos theta. This is only true in an inclined plane. Take notes of this. Very, very important in terms of physics. So whenever we are dealing with an inclined plane, our normal force is always equals to mg cos theta and not what? Mg. This is in what? In a plane surface, but this is what? In an inclined plane. Okay, right now let's begin with real calculations of the net force acting on an object. So let's begin with example number 1. Consider a candy box at rest on a table. If the box has a mass of 10 kg, calculate the normal force on the box. Okay, so let's find a solution to the problem right now. So we're going to look at it. Each time we're solving this kind of a problem, the first thing to do is to draw a free body diagram. So let me begin by drawing a free body diagram for this problem. The candy is on a plane surface, so I have a plane surface and this is my candy, and the candy has a weight, and there is also a normal force acting on the candy. Remember again that the magnitude of this normal force is equal to the magnitude of the what? Of the weight. So therefore, now that we have this, we can solve the problem. What do I say? We begin by saying that the sum of the forces is equals to what? The mass times the acceleration. And remember from this point that here the object is at a stationary, therefore the net force is equal to 0. So I can say the forces that are acting is the what is the normal force and the what? And the weight, which means that F net plus Fg is equals to what? Is equals to MA. And remember we said our F net here is equals to what? Is equals to 0. So I can simply say that F net, because it is not moving, that is why it is equals to 0. So if it is equal to 0, I will transpose the what Fg, which is the weight, to the other side and have F net being equals to negative Fg. That is according to Newton's what? Newton's third law. And from this point now, we can say the normal force is now equals to negative mg, which is what we are told to calculate. And we were told that the mass of this candy is what? Is 10 kg. So if it is 10 kg, once I have this, I can just say that Fn is now equals to negative what? The mass is what? Is 10 multiplied by the what? G, which is the strength of gravity. That is the what? The strength of the field of gravity, which is acceleration due to gravity, and that is what? 9.8. Remember, it is always acting downward. I know some of you are not familiar with this, but I want you to get used to this right now. If I draw a Cartesian plane, this side, okay, is the positive y, this side is my negative y, this side is my negative positive x, and this side is my negative what? X. So that means anything that is going down here, I am going to consider that to be what? Negative. And acceleration is always acting where? Downwards. Therefore, the value becomes what? Negative. Okay. So I will take that and make that become what? Negative 9.8. And then we deal with the multiplication for that. And once we do that and multiply negative by negative, that gives us what? Positive value. And our answer will now becomes what? 98 what? Newtons. Because we are dealing with what? We are dealing with a force. So this is 98 newtons. And that becomes the normal force acting on this particular what? Particular object. Alright, so just take note of that all the time and see. If you were not using this to be negative value, then there is no need to put a negative sign here. You're not going to obey Newton's third law. You will just say Mn is equal to what? Fg, and just do the substitution straight away and you get the answer to be correct. We will assume that you have taken care of the what? Of the negative sign. Straightforward. Okay, let's look at example number 2. Now consider your friend is pulling upward on the box by a string with a force 40 newtons. Question number 1 says, draw a free body diagram of the candy. 2, also calculate the normal force on the box. Okay, when you look at this particular problem, it seems as the problem is just a continuation of the example number 1. So, let's try and get a pictorial view of the question. So we can see that this is a table and this is the candy. The candy we were told is 10 kg. There is a normal force here, okay, and there is what? There is a weight also on this side. Right, this time around I'm going to make the weight to be longer than the normal force. Your friend is the guy who is just here. Okay, and this guy now is applying a force to lift this up. Okay, so there is a rope that your friend put here and it's now lifting the what? The candy up. If your friend is lifting this candy, pulling it up this way, it means that there are what? There are 3 forces that are acting, because remember, a force can be a push or a pull. So, we drawing the free body diagram for this, we're going to have something like this. And straight away we can see this is the normal force, and this is the what? Is the pulling force. And now we're going to have what? The weight. Now, this is what makes physics very interesting, and somebody who has the knowledge of physics becomes more intelligent than somebody who has no knowledge of physics. So let's look at it and see. We can see there are two forces that are going upward, and there is a force that is going in a downward direction. This simply implies, according to Newton's third law, these two forces must be equal to this force. That is simple as that. So the sum of these two forces is now equal to this force. That is why you can see the length of this is longer than this, and it is longer than this. It means if I combine these two together, it must be equal to this. So the magnitude of these two forces is now equal to this. So let's try and now solve the problem. To solve this problem, we can just simply look at it as F net is equals to MA, Newton's second law. And now what is the F net? It is the sum of forces. How many forces? 1, 2, 3 forces. So what are they? They are Fn plus Fp plus what? Plus the Fg. And that is equals to what? Ma. Now, take note and see something. What are we looking for? Our interest right now lies in a situation where we will be looking at the what? At the pulling force. Right? So if we are to look for, we have to look for what? The normal force in this situation now. Because we're giving the pulling force to be what? 40 newtons. So if I'm looking for the normal force, what you must understand is that when the pulling force was not there, the normal force was greater. Now that the pulling force is there, the normal force we are going to get in this calculation should be less than what we got before. Once we know that, then we are on the way to success. So let's try and make that situation. Let's work that out. Okay. So where is it? We are pulling the object up. So since we are pulling the object up, we know that the net force is going to be what? It's going to be 0. I'm pulling, but the object is not moving, so it's going to be 0 in that case. So this is the same as saying F net plus F pulling force plus the weight is equals to what? 0. Because we know I can say F net is equals to 0 here because I am only pulling. It's like I try to hold this and I'm trying to pull it, but this is not what? It's not pulling. But I'm pulling the force, I'm applying the force, but it's not pulling. So that is what is exactly what is happening in your mind. That's what you have to think of. So if that is true, then I need to do the what? The calculation straightforward from that point. So having Fn is equals to negative Fp minus Fg. Then when we come to this side, we're going to just straight away do the substitution from this point to okay. We have negative 40 because the Fp was 40 and there's a negative sign here. So negative 40 minus sign, this is 10, and already we said anything coming down should be negative, so negative 9.8. And when we do that, we're going to have what? Positive what? 98, and then negative what? 40. That gives you what? Positive 40, positive what? 58 newtons, and straight away that is what becomes the what? The final answer for that. All right. Okay, let's look at example number 3. Example 3 says an 85 kg person is standing in elevator that is accelerating down at a rate of 2.3 meters per second squared. What is the normal force exerted by the floor of the elevator? So we want to just look at the normal force that is being exerted by the what? By the floor on the elevator. That's what we want to look at right now. So let's see how to go about solving this problem. Here is the elevator Okay, so we can see there is a person that is in the elevator. There is a person in this elevator. Alright, so once we can see that there is a person in this elevator like this, here is our elevator that we have in, and this is the person, and we can see from this point that the elevator is moving downwards with an acceleration of 2.3 meters per second squared. This is the acceleration of the elevator. First thing to do is to find the free body diagram for this. If I look at the free body diagram for this, we can see that it's going to just look like this. We're going to have an upward force, and we are going to have a downward force. So this is the weight, and this is the normal force. And remember that we know definitely that the net force is in the direction which is what? Downwards. Okay, so the net force is in a downward direction. And we know that the net force is equals to MA. So if I've been able to translate this into this, where we have the elevator, the person, okay, and now the acceleration with which the elevator is moving, and they are moving in a downward direction. So the direction of motion is in the downward. Right. Immediately we know there is an acceleration. That tells you that the net force is not equal to 0. So if my net force is not equal to 0, let's solve the problem. We can apply Newton's laws. And we can say that, okay, our F net is equals to MA, and F net is now Fn plus Fg, and that is equals to MA. Remember that what I am looking for is the what? Is the normal force. So if I'm looking for the normal force, I will say that F net, Fn, which is the normal force, is now equals to MA minus, because I'm transposing the weight, and that becomes what? This. And if I have this, what is the Fg? It is the weight, and that can simply be that it is Fa minus what? Mg. And remember, the mass remains the same. The person is the same person inside the elevator, so the mass does not change. The mass is the same, which means this mass is common. And if the mass is common, I can simply work it out and say that my Fn is now equals to m into A minus what? Minus G. Okay, so we can see that the mass, as I said earlier, that the mass is common to both sides, so we factor out the mass, and now we have gotten this. I'm going to do the substitution from this point. Remember that we are looking at the downward motion being what? Negative. So if my downward motion is being negative, therefore we can say that our normal force is now equal to the mass, which is 85, into acceleration is also in a downward direction, so it's negative 2.3. Negative sign is this for this one, and now we have the acceleration due to gravity, which is also what? Negative 9.8. And now you work out this, and then we can just see what we're going to have straight away, that we're going to have what? 6.4 multiplied by 10 to the power of 2 newtons. And that becomes the what? The final solution for calculating for the what? The normal force in the elevator. Okay, let's look at example number 4. Example 4. We are to calculate the sum of the two forces acting on a boat. Alright, let's look at the boat. We can see that there are two forces that are acting on this boat. So, okay, so let's look at it that this is the ship, there is a force that is in this direction. So I'm going to name that force F1, and F1 is 40 newtons. And there is another force which is also in this direction, and that I'll call it F2, and F2, the magnitude is also 30 newtons. The angle here is 37.0 degrees, and this is 45 degrees. So remember that this has the x component and the y component. So I'm going to call the x component of this as F1x, and I'm going to call the y component of this as F1y, and I am going to call this one the same thing, that is x component and y component. So this is F2y and this is F2x. What we are looking for is to find the net force. So I need to find the forces in the x direction, the sum of the forces in the x direction. There is F1x and there is F2x. So I'll find the sum of these two forces, and I'll find the sum of the forces of these and this as well, and that should help me to find the magnitude of the what? Of the force itself that we are looking for. And after finding that magnitude, remember, force is a vector, it should have a magnitude and at the same time a direction. So let's check it and see. So straight away I'm going to solve and find my F1x, and to find my F1x I am going to say that it's going to be 40 multiplied by, because this is adjacent, so it's multiplied by cos of the angle, and the angle is 45 degrees. And if I multiply this by that, let's make use of the calculator. I'm going to have 40 multiplied by cos 45, and that is going to give me 28, or 28.28 newtons. And once I have gotten that, I need to find my F1y as well. And F1y is this. So this is the opposite. So I'm going to have it as 40 multiplied by cos, that's going to be sine. So sine 45 degrees. And if I work that out again, I expect that my F1y should give me also 28.28. Alright, newtons. Because you can see this is 45 and this is 45, so automatically they become a complementary angles. Alright, so I'm going to get this to be the same answer. Now let's look at a situation where we're going to find for our F2. So to find for F2, I am going to have F2x, and F2x is this, and this is also the adjacent. So it's going to be the force which is here, and that is 30 multiplied by cos what? This is 37 degrees. Right, and once I do that, I am going to have 30 multiplied by cos 37, and that is giving me 23.96 newtons. So I have gotten also for the F2x. I need to find for F2y. Okay, so we've gotten this, we have gotten this, and we have gotten this. We're left with one more. One more that we are left with is to find the F2y. F2y is here. Check this and see. This, if I look at the Cartesian plane, as I said earlier, we can see this is positive, this is positive, positive, here is negative, and this is also negative. So this is positive, this is positive, this is positive. So the answer for this is positive, Answer for this is positive. Answer for this is positive. Now we're going to look for this. This should be in the negative direction so that when you're working, you will be able to understand that now. So it is in the negative direction, our answer should be negative. So this is going to give me 30 multiplied by sine what? Sine 37. And if you do that, we're going to have 30 multiplied by sine 37. And we expect to have negative answer for that because it is in the fourth quadrant there. So we're going to have negative 18, okay, 0.05 newtons. Okay, this is also the answer for the other side. So I have gotten all the four forces, the components of the forces that are active now. So there are two x components, okay, and there are two y components. I need to bring them together and find the net force. So I'm going to find the net force in the x direction and find the net force in the y direction as well. So let's quickly do that. I am going to find the net force in the x direction, and that is going to be my f1x plus my f2x. And when I do this, I can see that my f1 is 28 comma. Please pardon me if I use a point or a comma, it means the same thing. Pardon me for that, okay? We can use any of them. So 28.28 plus, and now I am looking for this, which is f2x, and f2x is also what value? It is 23.96. So let's work that out and see what we're going to have. We're going to have 28.28 plus 23.96. So finally we expect to have 52.24 newtons. So the F net in the x direction is this. F net in the x direction is that. I need to find the F net in the y direction. So I am going to clean the side and make use of that. So my F net in the y direction is going to be my F1y plus my F2y, and the F1y is 28.28 plus F2y is negative 18.05. So let's work that out and see what we're going to have. So we have 28.28. Positive and negative will become negative, so 18.05. And I'm expected to have 10.23 newtons. Okay. So this is also the net force in the y direction. The net force in the y direction is this. The net force in the x direction is this. Now I need to find the total net force. So to find the total net force, I need to draw a vector diagram to solve for that. So I need to draw a vector diagram in order to find the total net force. So to draw the vector diagram, I am going to have it like this. Okay. And remember, the x component is here, is in this direction because it is positive, and the y component is also positive. The net is positive, so it means it is also in this direction. So this and that, and remember, this is what? Head to tail vector diagram. So I've gotten that. This is my theta, the direction that we need to look for, and this is given. The magnitude of the y component is 10,23 newtons, and the magnitude of the y component is, this is for y. The y is 10,23, and that of the x is 52,24 newtons. So I have gotten this. What I need to look for is this, which is what? F net. Remember, whenever we have anything like this is the right angle triangle, so we can simply apply Pythagoras Theorem. And if I am going to apply Pythagoras Theorem to solve the problem, then it's going to just look like this. I am going to say it's going to become F net squared is equals to 52,24 squared plus 10,23 squared. And once it is like that, we take the square root of this. So my F net is now going to be the square root of 52,24 squared plus 10,23 squared. And that is what we need to do to get what we are looking for. So quickly, let's punch this into the calculator. And then we get about 52,24 squared plus 10,23 squared. And square root of that will automatically give us what? Our answer, which is going to be 53,23 newtons. So the net force which is keeping the boat moving is 53.23. Alright, now we have seen the magnitude of the force that is keeping the boat moving. We need to find the direction in which the boat is what? Is moving. So to find the direction, because it is a vector, all we need to do is to apply trig properties. So we say that tan theta is equals to F net of the y divided by F net of the x, and that is going to be where we have 10,23 divided by 52,24. So the tan of that angle, and then we will take the what? The tan inverse, or the arc what? Tan of this. So finding the arctan of that, I'm just going to make use of this and say shift and say tan, and we press our fraction sign and say 10,23, and then it's divided by 52,24, and straight away what are we getting? We're getting 11,08. So this is 11,08 what? Degrees. So this is also the direction in which it is going, but where? We can see here it is in the first quadrant. Therefore, this is east and this is the what? This is our north. So it is what? It is 11,08 degrees north of east. North of east. So that is it that we have. So the net force is now 53,23 newtons, 11,08 degrees north of east. That is the direction in which the boat will be moving. Okay, now let's look at example number 5 and look at some work on the inclined plane. Example number 5. Determine the acceleration of a 12 kg block sliding down a plane surface angled at 47 degrees to the horizontal. Assume that friction is negligible. Now now let's look at this and solve the problem together. The first thing I want us to look at is, let's try as much as possible get a pictorial view of what we have, and then we can solve the problem. We are told by the question that there is what? An inclined plane. So this is the inclined plane, and there is a body which is found on this inclined plane. And according to the question that we are told that there is a 12 kg, okay, the mass is 12 kg, and the inclined plane is at an angle of 47 degrees. So this is what we have, and we are told that the direction of motion is here, which means that the body is sliding down. Okay, so if the body is sliding down, that is what we have, that the body is now sliding down the inclined plane. So the direction of motion is here. All right, let me just write there, make it easy, like, motion here, to show us that that is where the object is going. So the object is now sliding down, and we want to find the acceleration with which the object is sliding down. First thing that we need to keep in mind, or the most interesting aspect of the question, which we need to underline there, is that we are told by the question that what friction is negligible. The word negligible simply implies that friction is not what? Important here. We have to ignore friction. Small amount of friction. That's why it is what? Negligible. So it's just an infinitesimal kind of friction that we have. So very small, minute. Alright, so we're going to ignore that and deal with the calculation. So let's start by looking at the free body diagram. As I said, each time we want to solve any problem like this, the first thing to do is to look at the free body diagram. The free body diagram will give you the idea of the forces that are acting, and then you'll be able to do what? To deal with your calculation. So let's begin. I look at it and then put it this way and say, okay, this is my 47. Okay, so 47, and I will have my body in this side. Remember, this body is here, so there is a normal force to this plane. So the normal force is perpendicular, which we know of, that always normal force is perpendicular. And there is a weight, so the weight is now acting what? In an inclined form. So the weight is going to be in this direction. Let me use a different color. So we're going to have weight. Weight is here. And once I have weight here, these are the only two forces that are there. Remember, according to the question, friction is negligible. So if friction is negligible, once we have the weight here, what happens? The weight is having two components. So there is a perpendicular component, and there is what? A parallel or a horizontal component. So that will form what? A 90 degrees on the side. So this is my FGX. Remember, I told you I'll be using X and Y. And this is what? FG. Oh, sorry. This is FGY. And this is FGX on this side. So, right. And this is 47 degrees. So, automatically this angle here is also 47 degrees. When you are drawing the free body diagram, there is no need to draw the free body diagram using the components to draw the free body diagram. The free body diagram is just the normal force and the weight, that is all, because we can just automatically conclude that the components of the forces are forces on their own. So they are just part of what that make up this. So we're not going to include it in the what? In the drawing of the free body diagram. But I have included it here by using what? Dotted lines, to show you that I am just interested in using it in doing what? My calculations. So let's look at it. Now let's go into the calculations. I am here. Now we are going to look for the what? The acceleration with which the object is now moving with. So what I need to do is to apply what? Newton's second law, which says F net is equals to ma. So if F net is equals to ma, this is the acceleration that we are looking at. So that is what we're going to deal with in terms of the calculation. The question wants us to find the acceleration, which simply implies that the object is what? Is sliding. And if the object is sliding up this plane or down the plane, then what force is keeping this object sliding down? Is it the normal? Is it the weight? Well, the answer is it is the weight that is keeping it moving down. But if it is the weight, which part of the weight is keeping it? Is it the whole weight that is pulling it down? No, it is not the whole weight. It is what? Only the parallel component of the weight, that is the FGX, that is keeping the object moving downward, because this part of the weight is moving in this direction, which means that if that is working, we are expecting this object to rather move in this direction. But since it is not in this direction and it is in this direction, it tells you that the force keeping it in this direction is the what? Is the FGX. So therefore, the only force that is in that direction of the object, or the direction of motion of the object, is the what? Is the FGX. So which means that my F net is simply equals to FGX equals to MA. Alright, once I know that, then I need to find what FGS is. If you remember from our previous time, if you have forgotten, this is the angle, so this side is the what? Is the opposite. So if this is opposite, and now I'm looking at the opposite, I have to use what? The sign to deal with the calculation. So therefore, this is going to be FGX is now going to be sine what? It's going to be the FG sine what? Sine theta. And now what is the FG? We know FG is what? MG. So therefore, this is going to become what? MG sine theta. So my FG is now MG sine theta. So which means that I can equally say that this formula has become MG sine theta equals to MA. Because F net is this. And now this is my F net, which is this one. And that is equals to MA. We know the mass, we know gravity, the value of the gravity, we know the angle, we know the mass. What is not known is the what? Is the acceleration. So straight away, we do the substitution and solve for the acceleration. So let's do that. Now I can claim the Freebody diagram because it has assisted me in finding the expression to do the substitution. So the mass is 12. So I am going to put in there 12 multiplied by, this is my 9.8. So I'm going to use 9.8 and multiply by sine theta, which is also what? 47 degrees. And that must be equals to 12 multiplied by A. And what I am looking for is A. So if you do all these expressions together, we expected that the answer should become 7.2 meters per second squared. Right. So this is the acceleration with which the object is moving down the what? The incline. Remember, acceleration is what? Is a vector quantity. Therefore, what I have given is the magnitude. I need to show the what? The direction. So I will conclude finally by saying A is 7.2 meters per second squared what? Downwards. Downwards. Which means it is now moving down the inclined plane. Okay. Alright, let's look at example number 6. And this is going to be the last example that we're going to solve in this video. So example number 6. Calculate the acceleration of a 12 kg block placed on an incline of 47 degrees if the coefficient of friction between the block and the plane is 0.30. So look at this. These and the first problem we just solved, they are the same. The only thing that is changing there is that now there is a friction. Friction is no longer ignored. We need to consider friction now in the calculation. So let's look at it. We want to consider friction in the calculation. What do we say? Well, let me give a pictorial view of the problem. This is 12 kg and this is inclined at this. Still direction of motion is down the inclined plane, so we're still having it downwards the plane. Okay, which is the motion where it is going. And the next thing that we note is that this is sliding here, but rather just to make this one for you, I want to rough the surface a little, try to tell you that there is what? There is a friction there, because it is what? It is a rough surface. Alright, so now let's try. I'm going to draw the free body diagram for this now. What I have now is just the pictorial view of the question. Let's draw free body diagram for this now. Okay, to draw the free body diagram, I'm going to have my incline, which is 47 degrees. Then the object, which is here. Remember, the object is having it normal, and the normal is perpendicular to the plane. And there is a weight. There is a weight which is also found here. And just note that there is a friction now, so my friction is going to be in this direction. Okay, let me use a small f for friction here. Right, please, it doesn't matter. We can use a small f, we can use ff, you can use fr, whichever one that you use, the choice is yours, remember. Okay, all right. Now I have done this. This is my free body diagram that I have in there. But remember that this is having what? Is having components, and the components is what? The perpendicular component and the what? The parallel component. So because I only need that in the calculation for free body diagram, the question said draw free body diagram. This is the only thing I need to draw. But now the question never asked me to draw a free body diagram, but it said I should do the calculation, but I need the free body diagram to do the calculation. So I have done that. I am going to show the other part, which is the component of this. So I know the perpendicular part is there, and this is the what? Is the parallel part. So I have my FGY and I have my FGX. This is 47 degrees. Now it is complete. I can do the calculation now from this point. So let's quickly try and go straight into the calculations and see from this point. I want to do my calculation, so what do I have from here? Well, remember, we are looking at the forces that are parallel to this plane. And there are two forces that are parallel to the plane. These two forces which are parallel to this plane are the what? The parallel component of the weight, which is the FGX, and the what? And the friction. These are the two forces that are needed in here. So let's go and put that into the calculation. I state my Newton's second law, and after stating Newton's second law, what is the net force? We know that our net force is simply F, okay, GX plus what? Plus the frictional force, and that is equals to MA. And once I have this, we can then go back. Remember something. Remember this. We have frictional force, and frictional force is simply what? Mu, or the coefficient of kinetic friction, multiplied by the what? The normal. Multiplied by the normal. Now, check something. Friction is this. The mu, or the coefficient of kinetic friction, multiplied by the normal. But what is the normal? Remember, we said that in an inclined plane, I said to you that the normal force is always equal to the what? The perpendicular component of the weight. The perpendicular component of the weight in an incline. So the normal force is now equal to this perpendicular component. So which means that we need to find the perpendicular component, we need to find the what? The parallel component as well. So let's check it and see. For the parallel component, already we've done that before, and that is mg what? Sine theta. So what is going to be the perpendicular component? The perpendicular component, which is the FGY, is simply mg cos theta. In case you are not aware of that, look here. We can see this is the adjacent, and right now, if this is adjacent and this is hypotenuse, then we have to make use of what? The cos. And that's the reason why I made use of the cos for the perpendicular component of the weight. Okay, so we have gotten that part. Let's work out now into the problem. What is this now? We know this. Friction, we have stated what the friction is, so I need to come out clearly with my friction now. With the friction now, it is now going to be the coefficient of kinetic friction multiplied by the what? The mass times the gravity strength multiplied by cos theta. That is my frictional force. So straight now, I'm going to solve the problem by equating the whole thing now into my net what? My net force equation, or into the Newton's second law. So from here straight away, friction is, the parallel component is here, which is here, and that is what? mg sine theta plus what? Plus friction, and friction is also here, the coefficient of kinetic friction. Okay, coefficient of kinetic friction times the mass times the strength of gravity multiplied by cos of the angle theta. Okay, and all these must be equal to, it must be equals to the what? The mass times the acceleration. And once I got this, I can then put in or substitute the what? The values into this and solve for what? Acceleration, because everything here is known with the exception of the what? With the acceleration. But let's go straight, do the substitution, find the acceleration from there. Okay. Continue. The mass is given 12 multiplied by 9.8 multiplied by sine of the angle, which is 47 degrees. Okay, and then plus the mu was given 0.30 multiplied by the mass, which is 12. I think my board, so let me try create more space by cleaning the whole thing here so I can get in everything. All right, so let's begin again. 12 is the mass multiplied by 9.8 multiplied by sine 47 plus 0.30 multiplied by 12 multiplied by 9.8 multiplied by cos 47 degrees. And all these must be equals to 12a. And what I'm looking for is the a. So a is simply equals to all these divided by 12, because I can divide both sides. Okay, here by 12, here by 12. So that 12 can be cancelled out and I'm left with what? Just the a. And once that is done, what am I going to have? Divide all these on the calculator. We're going to get what? 5.2. Okay, and it's what? 5.2 meters per second what? Squared, because this is what? An acceleration. So we have to put what? The unit. Okay, now I put it But let's see. This is the acceleration and there is a friction, so which means that it can either be on down the incline or up the incline plane. So I can decide to work it out for either of them and say that, okay, the acceleration is 5.2 meters per second squared down what? The incline. Down or downwards. Or let me just put that, make it easy. Downwards, straightforward. It can also become what? This same thing upwards as well. So if we look at it from up or down, we're going to move on with the same thing, except we change the parameters in which we are working with. Alright, thank you very much. We're going to end this section here. And in our next video, what we'll be looking at is we'll be looking at the pulling system, which is going to be the last aspect of dynamics. And after that, we'll look at the next units that we're going to look at. Thank you very much for watching this video. And please don't forget to subscribe to my YouTube channel. See you next time.